Hi and welcome to Cherry Pie Math. Today we're learning about inverse operations, and this is just going to be very basic. It's not going to go into square roots or anything. You're going to do that in high school. This is just going to focus on very basic inverse operations and their uses. So to start out, let's go back to kindergarten and think about opposites. So here's a list of different adjectives. I want you to pause the video and just quickly figure out what all those opposites are. Okay, so hopefully it kind of looks a little bit like this. And as you might notice, some of them can be done by a couple different things, like sharp and smooth are opposites, but the opposite of smooth can also be rough. But most of the time, there's really just one thing that's totally different, just contrasting to it. So inverses are really related to opposites, but they're not quite exactly the same thing. So an opposite is more like the total contrast of something. So the total contrast or the total something totally different. I guess completely different. Completely. I don't know if there's an E in there or not. I teach math, not English. So opposites are just totally different. Another word I've seen to describe opposite is the reverse of something. Inverse is really similar to, I guess, reverse in a sense. So inverse operations mean the operation that undoes the operation before it. So I bring this up because the way we remember it and the way most of my students remember inverse is just like the opposite operation, which I don't totally love that word because it doesn't describe exactly what an inverse does. The inverse completely undoes it. So like we know that addition and subtraction are opposites, for example, but the reason that they're inverses is because if I add 5 and then I subtract 5, it's like it never happened at all. And that's really what an inverse does, is it just completely undoes the other operation. So the inverse of addition is subtraction. The inverse of subtraction is addition. And like I said, the reason they're inverses is because when you add something, so like you add 8 and then you subtract 8, you end up with 0. So addition and subtraction always end up in 0. Whereas multiplication and division are also inverses. So if I multiply something by 5 and then I divide it by 5, I will end up canceling them out. Multiplication. Yep, that's how you spell it. And this results in 1 instead of 0, because if you multiply something by 5 and then you divide it by 5, they don't come out to be 0. It comes out to be 1. Whatever you started with, I guess. So like if I have 1 here, then it would be 1. If I started with 3, I'd end up with 3. But that's something different, and this is why multiplication and division are inverses of each other, is because they end up canceling each other to become 1, and addition and subtraction are inverses of each other because they cancel each other out to be 0. You can't do plus 5 and then divide by 5, and that won't actually do anything. It won't cancel each other out, so they're not inverse operations of each other. So we can use inverses to rearrange numerical sentences that are true. So for example, when I say true, it means that their relationship will always be the same. If you have a 12 and an 8 and you put them together, you will get 20. But you can rewrite that in a couple of different ways. So for example, there's something called the commutative property, and that allows you to switch things and end up with the same number. So if I did 8 plus 12, that also still gives me 20. If I use an inverse instead, I can say 20 minus 12 is equal to 8, or 20 minus 12 is equal to, 20 minus 8 is equal to 12. Let me rewrite that nicely. There we go. So we will use this later on when we're talking about how to rearrange equations, but it's useful to see it now because you can see that we're just rearranging the numbers. We're not changing the values of anything. We're not changing what's true. We're just using inverses to rewrite it in a different order, I suppose. So commutative property only works with addition and multiplication. So here if I do 6 times 5, that also equals 30. But again, using inverses, I can rewrite it as 30 divided by 5 equals 6, or 30 divided by 6 equals 5. These last two, you can't use the commutative property right now, so I'm actually just going to change it so that it's 63. Sorry, let me change that so that it's 7 times 9 is equal to 63. And then I can change that around, so that can be 9 times 7 is equal to 63. I can also say 63 divided by 9 is equal to 7. Notice all of these contain the same numbers. I'm not changing any values. I'm just rearranging them using their inverses in different places. So in this last one, for example, I can say 35 plus 65 equals 100. Or I can say 100 minus 65 equals 35, or I can say 65 plus 35 equals 100. All of them mean the same thing. Depending on the way they're positioned, they tell a different story. Like in this one, I'm saying, oh, I'm starting with 12 and 8 things and I'm putting them together and I want to see how much I have, and I have 20. Like if I have like 12 apples and 8 more apples, I have 20 apples. Whereas this one is saying I had 20 apples and I ate 12 of them, so now I have 8 left over. The amount of apples is still there. We're just changing the story and the way it looks just a little bit to suit our purposes. So some things to remember is inverses undo their counterpart. And you're going to see different kinds of inverses throughout your mathematical careers. But at its core, not only are they opposites, but they undo each other. You can use inverses to rearrange numbers without changing the truth of a numerical equation, as long as there's an equal sign. Because of the equal sign, that's why we were mainly able to use the inverses. And we will always apply PEMDAS from left to right, even with inverses. That doesn't change anything. PEMDAS already accounts for that even. It already has multiplication and division together and addition and subtraction together because those are inverses of each other. Okay, I hope that helps you understand a little bit more about inverses and how we would use them, and good luck.